Communication as Fundamental Dimension, a unified framework for quantum mechanics, space-time emergence, and the nature of observation, by Roger L. Sheldon.
Yeah, this one's definitely ambitious. Sheldon's central question is, honestly, kind of profound. What if communication, not information itself, but the act and structure of communication, is actually the bedrock of physical reality? I mean, that's a big claim.
Very big. He's challenging the it from bit idea. You know, Wheeler's famous suggestion that information is the real stuff of the universe. Instead, Sheldon says, no, it's it from comms. Communication is more primitive. Reality is essentially the network of transformations that connect events, and things like information or even space-time just emerge on top of that.
Exactly, and that's significant because quantum mechanics and general relativity still haven't been unified, at least not in a fully satisfying way. Sheldon's proposing that maybe we've been looking at the wrong primitives. He thinks that by elevating communication, technically quantum communication channels, CPTP maps and all that, as the real building blocks, both quantum stuff and space-time can emerge more naturally.
Right, so instead of treating space-time as a background stage where things happen, and states as the main actors, he wants the actors to be these fundamental communication patterns. And just to be clear, when he says communication, he means the allowed quantum processes, not messages or language.
Exactly. His argument is that if you focus entirely on these channels and how they connect, you can actually derive things like the geometry of space-time. He even ties channel fidelity, the quality of communication, directly to distances in emergent space-time. If that sounds abstract, well, it kind of is, but it has bite. The more you degrade communication fidelity in some underlying network, the farther apart two events seem in a geometric sense.
He formalizes this with a sheaf-theoretic approach, which is, well, if you haven't seen sheaf theory, it's a way of carefully gluing together local data to get global structures. Here, it glues together clusters of communication channels into something resembling our continuous space-time.
And more, he claims this lets you derive general relativity, like Einstein's equations, as an emergent thing, not a given. By treating the entropy, or cost, associated with channel communication as an action to be extremized, you get the space-time metric and gravity as large-scale, second-order variations in this communication structure. That's wild.
Yeah, and he's not shy about predictions either. There are tweaks to the way entanglement, think EPR pairs, should decay over distance, specific patterns that could show up in high-energy collider data, and even quantized photon arrival statistics. It's quite a claim. This is actually falsifiable in several ways.
Shall we admit, by the way, that reading this made us both Google, what is a CPTP map, like at least twice? Or maybe that's just my confession.
No, that was totally me too. I keep seeing completely positive trace preserving and thinking it sounds like a meditation mantra, not a physics concept.
Same, but that kind of connects to Sheldon's larger point. The universe may not be made of things, but of ongoing interrelated processes, a kind of eternal passing of the message that gets compressed into what we experience as reality.
Which, if it's true, might also explain why physics struggles so much with observation, the measurement problem. In his model, observation isn't a weird quantum event, but just another compression, where a rich set of underlying communications gets squashed into a simpler state once we interact with it.
So, I guess for listeners, the main takeaway is this. Research like Sheldon's is a reminder that science isn't just about discovering facts. It's about building frameworks, then seeing if they hold up. Maybe communication really is the more basic stuff of reality, or maybe this is just a useful lens for exploring some unsolved mysteries.
Either way, it's a nudge to stay curious, question what you think is fundamental, and remember that even the deepest equations might just be compressions of something more dynamic, and maybe even more beautiful underneath.